So this is, I'm going to present you the integrating MRV methodologies and incentives in order to reduce nitrogen oxide emissions in carbon farming. Next slide, please. This is the whole value chain that concerns us. This one that we usually mention, like from farm to the fork. So the whole idea is to present to present and develop methodologies and tools that will serve this chain from farm to fork. Next slide. So the purpose and the scope of what we are developing. The purpose is to provide standardized methods for farmers, ranchers, and forest owners in order to estimate greenhouse gas emissions and incorporate nitrous oxide for their operations. To estimate the nitrous oxide impacts of current and future conservation practices and assess performance of relative programs like soil health. The methods that we have to develop to be aligned with the international greenhouse gas inventories where appropriate, allowing farm level data to be comparable to national estimates, and to serve as the scientific basis for the greenhouse gases estimation tools. The scope of this was to develop a cost-benefit methodology that will focus on site to evaluate the emissions and sinks and support the top-down validation of this. Next slide. So the key drivers of greenhouse gas emissions from soils, we can see in short here. We have the land use and land cover. We have the temperature, the humidity from those two, mainly from the climate factors, soil nutrients, and the type of vegetation. Next slide. So why are we focusing on the nitrous oxide? In short, what we know is that the nitrous oxide, it is 273 times more potent than CO2 in terms of its heat trapping ability. And secondly, because the agriculture sector is the main responsible from the global anthropogenic nitrous oxide emissions, because 60% of those emissions came from the agriculture sector. The key drivers of the nitrous oxide emissions in agriculture soils, they have to do with soil moisture. The most there is moisture in the soil, and the most it remains in the soil. This leads to denitrification and nitrous oxide production. Soil texture, when we have coasted, sandy soils, these tend to have lower nitrous oxide emissions than the more compact, more clay soils. The nitrogen inputs, it has to do with the fertilizer. When the more synthetic the fertilizer is, it can lead to greater nitrous oxide emission. And the tillage, that can actually affect the structure of the soil, thus can affect the aeration of the soil and the soil moisture of the soil, and in this way affect the emissions of nitrous oxide. Next one. Key points in developing this MRV framework in the context of carbon accounting and certification are to enable accurate tracking of nitrous oxide emissions in food production, to support targeted strategies for reducing the agricultural nitrous oxide emissions, to enhance the accuracy and consistency of reporting frameworks, to align with the European Union carbon removals and carbon farming certification regulation, to addressing critical gap where the missing cornerstone in existing carbon accounting system, and finally to provide reliable data for all the relatives that need these data, like business, policymakers, stakeholders, etc. Next slide. So for a review that we have done regarding the solutions for monitoring of this type of greenhouse gases fluxes, we find out that we can sum them up in 4 different solutions that they are different to each other in terms of accuracy, in terms of cost, in terms of if they involve portable or no portable equipment. So taking all these things into account, and what we intend to do, and I'm going to present you next, is we finally select what fits better. So next slide. So the Balkan Environment Center supports an MRV system at pilot scale through a cost-benefit flux monitoring approach. For this, we are working in a few pilot fields. In order to, we have made a system of data collection in order to feed the models that will provide us the results and the answers that we need. And the data, in order to feed these models, we get the data from in situ soil sampling, from monitoring of fluxes in canopy level, mainly in trees and tree cultivations. For measuring the fluxes in soil level, we are using jumpers. I'm going to present them next. And obviously, we make use of the remote sensing and Earth observation data, which is our main focus. Next slide. So this is where we were the year before. This is a field diagnostic toolbox that we presented in the previous Carbon Farmers Summit in Valencia the previous year. So this is where we have been 1 year before, developing this type of portable and affordable diagnostic toolbox. And in the last year, we have moved on to develop and propose more things, more solutions. Next slide. So we are focusing on developing methods of sampling the main greenhouse gases, the 3 main greenhouse gases, and the whole methodology is conducted using various techniques depending on the measurement objective. For the soil, we're using closed soil chambers, measuring the gas fluxes that came out from the soil. We use open type of chambers for recording gases in the canopy level. We use laboratory analysis by using gas chromatography. And furthermore, we use the Earth observation methodologies in order to define different modules regarding the climate parameters, soil parameters, or management practices. Next slide. These are the methodology that we use to measure the soil, the fluxes from the soil with this type of closed chambers that we put them in a selected points in the soil and in the selected time within the cultivation period. In order to, in this chamber, we collect the emissions from the gas emissions from the soil, and in a selected time lapse, we are measuring the concentration of these gases in order to convert this type of concentration in fluxes. Next one. At the canopy level, the idea is more or less similar to the one that we apply in the soil level, but we are doing the sampling at canopy level using the techniques of passive sensors, type of NDIR sensors, that they are placed at different heights within the canopy. With sampling tubes, we collect air samples in order to make the laboratory analysis. And the idea is to have at least on our pilot fields, we have at least one station of this type. So we get for the whole year, we have a continuous recording of the fluxes at the canopy level. Next slide. The NDIR method, non-dispersive infrared method that I have already mentioned, it is used to measure these three main gases. It is based on the absorption of the specific infrared wavelengths by gas molecules. So the idea how it works is that an IR light source emits radiation through a gas sample. A filter allows only the wavelength absorbed by the gas to reach the detector, and the detector measures the decrease in radiation intensity that it has to do with the gas concentration. So in this idea, we measure with different type of accuracy, carbon dioxide, methane, and nitrous oxide. Next slide. The advantages of this method is that it has a high accuracy in CO2 measurements. We can get continuous and real-time measurement. It's not affected by other gases when proper filters are used, and it has a long lifespan and low maintenance costs. Disadvantages is that it's difficult to measure nitrous oxide with this methodology because it can't measure nitrous oxide at low levels. And the sensors can also affected by a little bit extreme temperature or humidity. And it's more expensive than other methods of, for example, the electrochemical sensors. Next slide. The gas chromatography that we use in the laboratory is more accurate, but more expensive as well. So the idea is that we use a combination of those two. We use mainly the sensors that I have presented before, and we use the laboratory in order to validate the sensors and to know that we're getting good results from the sensors. So the laboratory isn't our main principle in terms of measuring. It's our main component in terms of validating the sensors. In the laboratory, we get the the air samples from the chambers using syringes or bags. We transport them to the laboratory, inject them into gas chromatography, and we can, with gas chromatography, we can measure the three selected greenhouse gases. Next slide. This is the type of equipment that we have in the laboratory. It can work with two different type of sensors or methodologies, each one with for specific purposes. Let's not get into detail into this more technical aspect. Next slide. So this is more or less how it works with the two different type of methodologies. And next one. And these are the advantages and disadvantages of the laboratory methodology of the gas chromatography. The advantage is that it has a higher sensitivity. It can detect low levels from nitrous oxide, methane, and CO2. It can make use of automatic sampling, so it has the ability to handle multiple samples with one autosampler. It has good analytical accuracy and reduced operating costs. Let's hope that the screen is not turning off. The disadvantages of this. Thank you. Yeah. It is a higher cost of buying the equipment. The one sensor, the FID sensor, requires hydrogen and air for the flame operation, and it requires also training for the proper use and maintenance. Next slide. So, let's say the whole idea is how we collect our data in order to feed the models. The data that we collect, they are in these four different categories. We collect data, climate data, data of agronomic management, soil data, and data of air chemistry. So for each type of data that we collect, we have made this type of categorization in order to get the indicators that we need to measure, which is the temporal and spatial resolution of each type of indicator, and which are the source that we can actually get this type of measurement. So here in short, we present for all these indicators that we measure this categorization in these four categories. And next slide. So finally, after the review that we did, which method fits better our purposes, we came up with a conclusion that the best is a combination of these two methods: the NDIR method, that is based on the sensors, and the gas chromatography method that is based on the laboratory. The main method, the first method, that is it's portable method. It has low cost. That is, it's very important, and we don't have this type of sensitivity that we need, but we get finally the sensitivity that we need by validating this method by using the laboratory and the gas chromatography method that has obviously a better sensitivity but higher cost. So a combination of these two is finally the ideal solution. Next slide. So by integrating our innovative MRV services. They promised that this will significantly enhance the accuracy and reduce the cost of MRV for carbon farming projects that are focused on reducing the fertilizer emissions, like the one that my colleague Nikos from Proba will present you right away. And we have the challenge is to make these projects more robust, so they will be of greater use for the carbon farming market. So thank you very much, and I pass the floor to my colleague.
Hello everyone, thank you George. First of all, to thank each and every one of you being here. As we mentioned before, like a huge participation in the summit, and I hope a good outcome out of it. Yeah, next slide please. So, next slide. Okay, so I'm from Proba, we're a startup based in Amsterdam. We believe that we can make the agri-food supply chain green again, and our focus currently is the incentivization of the enhanced efficiency fertilizers. Next slide. To give some context, probably most of you have a background, but fertilizer-related emissions can come from the manufacturing side, and then transportations, and then the application. For the reason for this presentation, we focus more on the application side and the emissions coming from the soil. Next slide. So there are technologies that have been proven that can reduce emissions from the soil and from the fertilizer inputs. And next slide. And yeah, here is a bit of a high level how each intervention can reduce emissions from from the production, transportation, and field emissions. We will focus now on the nitrogen stabilizer, which is a program that we are already working in IFA. Next slide. Yeah, they are good candidate, easy to implement, cost effective, and there have been a lot of indication that there is effectiveness in reducing emissions. Next slide. We work on this program together with the International Fertilizer Association and several industry leaders. Next slide, please. And we try to build a program that actually focus on implementing technologies like the nitrogen stabilizers in order to reduce emissions from the agricultural sector and at the same time maintain the same crop yields. Next slide. To add on this, we are currently highlighting the fact that the insetting mechanism in this kind of projects, where we focus on the agri-food supply chain, is a mechanism that can unlock more potential because of the reasons that the companies can support and start this kind of projects and reduce their own scope 3 emissions. In comparison, in contrast with the offsetting, as we all know that companies use the offsets in order to compensate and realize residuals of emissions, either that they are outside of their supply chain. Next slide. So we need to make sure that everybody is paying the fair price, in the sense that every actor, every stakeholder who's included in the supply chain can commit and financially and also by promising that they will, for example, from the farmer side, adopting this kind of practice, fertilizer producers doing more R&D, and then the processing retailer and in the end the consumers, maybe they have to pay some green attribute. Next slide. So what do we need to support a good insetting scenario? Next slide. We identify 3 components, of course there are more specifics. First of all, a greenhouse gas methodology. Secondly, appropriate emission factors in order to quantify the impact. And third, a strict governance in order to share the benefits to everybody in the supply chain. Next slide. So, to start with the methodology, science-based, giving certain guidelines to the project developers how to quantify, how to monitor, report, and verify their emissions and the reductions that they're claiming. Of course, importance is given to the MRV, the monitor, report, and verification, and monitoring technologies like the one i-BEC introduced before can be valuable for these reasons. The methodology that we're building right now, it will be for public consultation mid-April. So I welcome every one of you, if you could provide some feedback, some comments on the methodology. Next slide. Secondly, as I mentioned, is the accurate emission factors. We are focusing on identifying emission factors with less uncertainty in order to be credible of what the claims are. And actually need to reflect the real world conditions, because we know each project, based on the location, the specifics, based on the soil, the mean precipitation, mean temperature, the emissions, and the reduction that can happen and vary. Next slide. For now, what we are working on, we start with data collection, and we're focusing on building a database which actually collect data specifically on nitrogen stabilizers for now. What we have, the scientific environment, of course, there have been studies, experiments focusing on that. We established some quality criteria in order to do a proper screening of the available studies. And from there, we compile them and we build this database. It is an ongoing work, but we are positive that it will reach a level, the version 1, which will have enough data in order to identify some scaling factors. And in the end, maybe in the future, we use it for some modeling approaches. Next slide. A step further in this quantification can go by using advanced monitoring technologies and tools. We can ensure reliable data and, of course, as I mentioned, credible emission reductions, further improvement of the available emission factors, reducing their uncertainty, and, of course, being more cost effective. Next slide. The third component is a strict governance to guarantee high integrity claims. Here you can see we start from the project developers that they need to identify and to quantify their impact, and we move to the verification and validation bodies that their role is to verify, and from there, based on the standard registry, which is something that Proba provides, we issue the impact units. And then proper transfer and report of the, for example, the food company reporting the scope 3 emissions. Next slide. Yeah, to give to all this, let's say, more theory, a real world example. Currently we are working with AgriFree, a Foodchain ID, on a project in the Netherlands. We have included with several potato farmers. To give some context on the information, okay, again, crop type is potato, the crop price is around 200 euros per ton, and the abatement cost can vary from 50 euros to 100 euros per ton of CO2 equivalent. Emission reductions can vary again from 1 to 2 tons of CO2 per hectare per year. Of course, these numbers, small for illustrative purposes, they can vary based on the context of the project. Again, as I mentioned before, every project has specific soil characteristics, specific crop types, specific climatic conditions that actually can influence the impact of the nitrogen stabilizers. Next slide. So how the abandonment cost falls into the wider. Here there is a slope of this graph. We can see different interventions on the fertilizer industry, from green ammonia to nitrogen use efficiency, control list fertilizers, inhibitors. In Proba, we believe that is an affordable intervention, and we promote its adoption. Next slide. Here we have a comparison between different mitigation approaches. What we see on the nitrogen stabilizer with the insetting mechanism, as I mentioned, the low cost of the abandonment, the low abandonment cost, the time of the impact, it can be immediate in the sense that we can see the impact at the end of the crop season and the end of the year, and easy to implement. No major changes needed from the farmers. We are talking about a switching from the conventional used fertilizer to the one with the addition of the stabilizers. And of course, high credibility on reporting the scope 3 emissions from the food companies. To give some comparison between, for example, offsettings, you know that in the end, the scope 3 credibility, it can be a bit more questionable, and of course, regarding regenerative agriculture, for example, cover crops, it may take a bit more time in order for us to actually see the impact that this intervention had. Next slide. And to move to Maarten from Foodchain ID. Really important, we need appropriate verification and validation of these greenhouse gas projects that experts can provide and make the projects more credible and in the end issue impact units that actually matter. And Maarten, if you can continue.
Yeah,
thank you so much.
Thank you, Nikolaos. Next slide. So I'm Maarten Haan from Foodchain ID. Our company supports other organizations if they with food safety or things like carbon assurance. So let me explain a little bit on what we do in terms of carbon assurance. There are basically three types of services that organizations can ask from us. If they're unsure kind of in how their current supply chain looks like and they need support to map that and to set up a strategy, we offer kind of a pre-assessment where we take the client by the hand and basically show the different methodologies and help to set it up. The second approach is they already know and have a good idea about where their scope 3 emissions are in their supply chain. So then we help them with setting up the assurance. I'll talk closer to this. Okay, yeah, no problem. So then we help them with that aspect of setting it up. And finally, there's the carbon credit verification, and that's have to say between the second and the third option, it's less popular because also if you want to report and make claims in terms of SBTI, then the insetting is part of it, but carbon credits aren't. If you go to the next slide, please. So what does that assurance look like? Basically, we start with first gathering the data, understanding. Okay. Okay. Yeah, no problem. Is better? All right. So first gathering the data and all the relevant documentation. Then secondly, we go into validating that data, starting with remote desk audits. And if needed, we also go to the farm level to verify some of the claims if that's required. And then finally, there's a step, I think Nikos also highlighted that, you also want to make sure that those claims stand up in the supply chain. So there could be different actors in the supply chain that want to take advantage of those CO2 reductions. And then, how do you manage that in the supply chain is also a service that we can offer. Next slide, please. So what sets Foodchain ID apart from other organizations that support this work? Well, we're focused purely on the food business. So other verification companies, they have a whole scope of different activities, but our expertise is the food business. We have PhD level expertise. We already work many years in the agriculture business, so we know what we're talking about. We're accredited to do these types of analysis, and again, we know how to make it work in the supply chain itself, from farm to fork, as was shown in the first slide of this presentation. So, thank you. That is what I wanted to show today.
Thank you so much. Can I have the slide, please? Okay, so good morning, everyone. My name is Federica, and I'm representing Zwart GmbH, which is a German company. And today we have already heard about carbon claims and a lot talking about Earth observation. And since we are a company that mainly provides Earth observation data and services, I would like to present what we do exactly with remote sensing, and hoping that this might be helpful for those who are here. I know that probably most of those that are here probably are already expert with Earth observation, so I won't be too much into details. I will try to broadly present what we have done and what we will do next. Next slide, please. We are part of the ESA ecosystem, and in particular we are based in Darmstadt, where there is one of the ESA center. And we started actually talking about soil organic carbon and the use of Earth observation since 2018, and when we were a startup, and now we are a small medium enterprise. We collaborate with several organizations and universities, and we also have established a spin-off with the University of Venice in Italy. Next slide, please. Okay, so I need the QR code. We just want to have an understanding about what do you think about Earth observation for carbon farming. So if you can show the QR code, please, for the Mentimeter. Okay, I'll leave you some seconds for you to scan and answer the short question. Not the right code. And next QR code, I think that it's the same QR code of before. I know you have to scroll down, they say. Okay. It's always the same. Okay, don't worry. The question was if you are familiar with Earth observation, so maybe we can turn into analogic tools, and so just raise your hand if you are familiar and you use Earth observation for carbon farming. So those who say yes, just raise your hands up. Okay. Thank you so much. So next slide, please. I'm happy to see that there is someone that is experienced, but also that someone that maybe is not very familiar. So I will try to provide some inputs for you. So maybe if you heard about Earth observation for carbon farming, you heard about there are some limitations in this field. The fact that, of course, what we can see directly from satellites, it's what's on the soil, but we cannot go beyond the soil. And if we are talking about carbon farming, maybe this can be an issue. And of course, if we want to then go to other methods like using soil sampling from laboratories, there might be inconsistencies between what we see from satellites and what we analyze from labs. And of course, the satellites, and I'm referring especially to the open ones that we have available, have some limitation regarding the bands that are available at the moment. Maybe in the future, some of these limitations will be overcome, but for the moment, that's what we have, and we have some limits. Because of this limitation, this can create a problem, especially when we go to MRV. Because of this, we cannot really use Earth observation for MRV. However, there is something that we still can do with Earth observation, and that in a way can advantage MRV and carbon farming. And for instance, just to mention something, of course, we can monitor some proxies that are connected with carbon farming. Of course, there are some bands and satellites that can sense better data related to organic matter and soil moisture. And of course, we can integrate, there are ways to integrate soil sampling and Earth observation data. And maybe the most important one, that we can use Earth observation data as a time machine. So we can go back in the past and see what happened. Next slide, please. So the idea is that we can reverse this approach, so this view, and try to understand and use these advantages in order to build something that might be useful for carbon farming. And this is what we are trying to do with SCORE, which is a feasibility study co-funded by ESA, where basically we are trying to develop a rating system for three main ecosystems, for agricultural areas, for coastal areas, and for urban areas. Of course, you can understand that today we will focus only on agricultural areas. Next slide, please. In order to perform the project, of course, we have some pilots involved, and you can see here the map of the different pilots that we have involved. Next slide, please. Next slide, please. Okay. Let's start from the beginning. So what's the idea behind the rating system that we are creating? The idea is that, of course, with satellite data, maybe the big advantage that we have is that we can go back in the past and so understand what was happening to my soil some years ago. So the idea is that I can set baselines maybe for my carbon projects, not only taking into account where I can monitor and see now at time zero, but I can also see what was happening in the past, and therefore with the auxiliary of artificial intelligence also to predict maybe how my soil is going to behave in the future. Next slide, please. And basically, this is the idea of that is at the basis of the rating system that we have created. It's not readable very well, the new, but it's a new compared to what maybe I have presented in other presentation, because hi. So because we have worked, of course, with the different pilots, and so we have updated what we have done. And basically, the scale is divided into three main moments. So we appoint scores based on what happens to your soil in the past, what happens in the present, so the time zero, let's say, and what will be in the future. This system takes into account several elements, indicators. So we consider vegetation indexes, we consider evapotranspiration, how the stress of the plants, phenological cycle. We consider elements connected to the soil, if they are available, taking into account, of course, data from soil sampling, otherwise from available data set connected to soil texture. We monitor above ground biomass and then the organic matter. So, and of course, we correlate everything with some other auxiliary data like geometries, climatic data, and so on. So, all these complex systems that we have developed can be synthesized into a scale, basically, of colors or simply letters. Next slide, please. And you can see here let's say a representation of how the maps will come. Maybe I will come here so it's easier for everyone and also for me. So you can see that basically what we have done is to map and also to represent the different plots according to the scale. And what do they represent? I don't know why the third one is blue, but it should be yellow. In any case, you can see here that these colors and these letters, basically they should give you an idea of what is the situation of your soil, of your plot in this case, what is their capacity of storing soil organic carbon, and also what is the capacity for them to host carbon projects. So usually lands that are located in A are those that have already almost reached their capacity to store soil organic carbon, and this is associated usually with forest or with grassland in a very good condition. Then we have plots that are located in B or C usually permanent crops that have a good sock content, but at the same time they also have, they still have the possibility to perform some carbon projects, even if not limited. And probably the most important class is the C class, where we see mainly rotational crops or plots that host rotational crops, that basically they have a moderate stock level, and so they are the suitable ones to host carbon projects, considering the cost-benefit ratio. Then we have the two lower classes. These are those that have the lower amount of stock, and actually it doesn't mean that they cannot host carbon projects, just that they need more investment because maybe some agricultural practices needs to new agricultural practices needs to be performed. Next one, please. So what's the advantage of this methodology that is based on Earth observation? The fact that we have a global coverage, so we can apply this methodology anywhere, that we have time series, so that we can go back for sure 5 years, since 5 years ago, and in some cases even 10 years ago. Weekly updates, it depends on the revisit time of satellites that goes between, let's say, 6 and 12 days, depending, of course. It's a standardized methodology, so it's a method that we have developed, but at the same time, it can be customized with the integration of soil sampling, if available, or any other data that the farmers or anyone has. And it's low cost because it's mainly based on Earth observation and in particular on open source satellite data. Now that we have this, developed this system, what are the applications that we have seen? We have identified two main applications. One is for the baseline definition, and the second one is for monitoring the carbon project. Next one. So, you know the definition of baseline, but I just want to review it together with you. Basically, the idea is that we have a net carbon removal benefit when this is something that goes above the baseline, and of course we remove the gross, we remove the, let's say, the emission that are produced by the activity that I'm performing. And so why we should focus on baseline? Because when we set the baseline, this gives us a lot of useful information for carbon farming. So first of all, we have the possibility to monitor the emission, then to define what's the additionality, that is one of the most important factors to address, and also, especially if we have the possibility to go back in the past, also to understand if there was greenwashing in this location. Next slide, please. So let's stay on the baseline. So if you recall the previous idea, so the fact that we can integrate to data that I collect now with data that I collect in the past, this means that now I can set the baseline not really at time 0, but at time 0-5. So it means that the baseline that I consider, that I set now, not only take into account the moment I decided to start my carbon project, but also what I did before. And we believe that this can be very valuable, especially for contrasting greenwashing, and to ensure especially that the first movers, what are called the first movers, are recognized and give recognition compared to those that maybe have decided to apply some agricultural practices in order to reduce the baseline. Of course, since we are using satellite data, we have the possibility to develop a baseline at project-based level or even at plot-based level. And also we have the possibility to distinguish between what are the different variation connected to the specific crop. So maybe it's a rotational crop, so of course there are some periods where you have bare lands and another period where you have, I don't know, some other crops that are useful for nitrogen reason. So this variation can be detected and differentiated compared to something that is directly connected maybe to the agricultural practices that I'm performing, and so to the carbon-related variation. Next slide. And also this can be used for monitoring purposes because of course I can monitor the trends of carbon sequestration capacity over time. We can set some alerts in case we notice that your project is downgrading based on the rating system. And also we can simulate what is the best agricultural practice that you should apply. Next slide, please. So regarding the baseline and in general, the information that we have collected about also during the project, basically we have developed this dashboard, which you can see also because it's available in the poster, where basically you can have the possibility to test what I've said. And this is basically an example of what we did in France. The idea is that if you are a French farmer, maybe you can take this map and check your soil and basically try to understand, according to the scale, okay, what's the situation now of my plot? What can I do? Can I do a carbon project? So here you can have some indication about your plot. You can see here that there is the classification that I showed before with the description, more accurate, of course, than the ones that was for graphical purposes. And then you have some other information regarding your plot. So you have some information about your crop type, and also about the residual biomass that is in your plot. And we believe that maybe this can be helpful for biochar purposes. Next slide. But in addition to this, there is also the possibility to try to test this simulation tool that we have developed, where basically you have the possibility to select the area, in this case we are in Germany, and select the kind of, let's say, crop type you want to work with, and then to compare several agricultural practices and to understand which is the best one in order to improve the storage capacity of your soil. Here you see, for instance, the comparison between the two, and you can understand by numbers what's maybe the most effective one for this plot. Next slide, please. So we have developed this ecosystem of services, and as anticipated, you have the possibility to see the open source portal that we are developing. What I brought here, it's just a demo, so you will see a more structured and a nice portal later on, but it was just to give you an idea of what we are intending to create, and also because we believe that open source is the future, as also some other companies are demonstrating. And so we believe that it's with these tools that we can facilitate and create trust in carbon farming. So in addition to open source resources, of course, we will also deliver some other services that are more accurate, using higher resolution, and so release them more often, allowing the possibility for everyone to use, not directly only from our portals, but also from integrating with their own portals. Next slide, please. So who should use this? The idea is that we were thinking about this system, thinking that it could benefit really the entire value chain of the carbon farming and of the market. Because of course we believe that the first one who should use these services should be farmers and carbon developers, because during the pre-assessment phase, they can understand if they can host carbon projects, and also to understand what's the best agricultural practice that they might apply. and also to have a support for managing their carbon projects once they have started the project. And of course, we have identified some other potential users, like insurance, in order to reduce risk associated with carbon leakage, and those that are selling or buying carbon credits in order to help users to understand, okay, where should I invest now? What's the best project that may give me something back? So next slide, please. In conclusion, we believe that these score and services that we are producing should deliver more trust, value, and protection in the carbon market, and so to support the entire value chain. Next slide. Just one last remark. As I said, you can see for the poster, and so you can have the possibility to have a look at the platform and also provide the feedback. Next slide. And we'll leave it here. And you don't need to scan them now. They are also on the poster, but the idea is that these are the QR codes in order to visit the demo portal, and also if you want to give us a feedback, this is very helpful for us. Thank you so much.
Well, thanks everybody for coming today. My name's Penelope Nagel. You might be thinking to yourself, why is there a woman from California at the EU Carbon Farming Summit? Doesn't make a lot of sense, does it? I'm actually here on behalf of the IEEE and the Geoscience and Remote Sensing Society because, next slide, or first slide. One more. There we go. We are looking to create a standard to validate innovations in agricultural testing, and this is a global problem that we all need to be on board with. Why the IEEE? Why not one of the European groups? Again, this is a global situation. The IEEE is a public charity. It is the largest international organization that basically is about professional and is dedicated to advancing technology to benefit humanity. There's a QR code on there. We will show that at the end as well. Next slide. Interactive part of the presentation. Is the cup half empty or is the cup half full? Let's go with, is the cup half full? Who thinks the cup is half full? Who thinks the cup is half empty? All right, and how should we measure that? Anybody have any ideas? We've got people from all over Europe here. How should we measure that? Kostas, how should we measure?
The upper part is larger than the lower part.
Okay, well, I'm going to let you know that everybody that voted, the cup is entirely full. The real question is, what is it full of? And that's what we're here to talk about today. Can I get the next slide, please? Okay, look at what we're measuring. When we look at greenhouse gases, most of the air is full of nitrogen. What we're actually measuring as far as greenhouse gases is extremely small. So how should we measure that? Should we depend on 40-year-old technology? Should we depend on 80-year-old technology? How are we going to advance this initiative if we're using old technologies? Well, right now, we have no way to validate new innovations, and that's extremely important. Next slide. Okay, well, what we need to do is we need to unite diverse governing bodies, meaning we all need to work together. So it's not just Europe, it's not just the Americas, it's not just Oceania, Africa, Asia, it's all of us. So in order to make true change, we need to be working together. And again, the IEEE is the perfect organization to do that because we have no bias, we have no political affiliation, and we are a global organization. So when we look at that, we basically need to look at the challenges facing carbon credit verification. Next slide. So right now, there are a number of things. We need to have data, it needs to be available. We need to be able to have the right methods, and number one, it needs to be cost effective. So most of you in the verification process understand that validating carbon credits is extremely expensive. Traditional test methods are not conducive to making this actually economically feasible. So how are we going to do that? We're going to have to rely on new innovations, and we're going to need a process in which to validate and verify those. Next slide. So unlocking the secrets of greenhouse gas inventory. A step-by-step process. We need to, again, define, we need to collect, and we need to quantify. And how are we going to do that with existing methods? We need to advance those methods and include new innovations. We've talked about a number of those today already. Thank you, everybody, for setting me up for success here. But we need to work together in order to do that. So next slide. The opportunity that exists here is enhancing trust and boosting user engagement. Farmers are skeptical. At least in the Americas, farmers are extremely skeptical. So how are we going to push this on a global scale? We need to adopt user engagement. We need to change public perception in some areas. And how we're going to do that, as you see up here, there's been a number of global scandals regarding fraud, greenwashing. Those are all big concerns in this market. I know none of us want to talk about that. I'm not here to throw any of these companies under the bus. So next slide. The solution is that we need to establish a standard to validate these innovations. And this standard will provide science-based, unbiased group of stakeholders in making these decisions on how we validate these carbon credits. So next slide. Currently, there are a number of resources available as far as protocols that we can use. There's county, there's city, there's by industry, but how do we validate that baseline testing that we're using in order to create these standards? Well, that's what we're here to accomplish. Next slide. There are also a number of climate calculators. We've heard about some today. Those are not standard across the board. If we're going to monetize a carbon market, we need to be able to sell those internationally by making sure that everybody's communicating and talking together. Next slide. So again, we really feel that the IEEE is the perfect group in order to create a standard to validate innovations in agricultural testing. And basically a way to look at new innovations. Next slide. We've got a couple ideas on how we could do that, but we need to look at those a little more scientifically. A lot of the methods that we use can change from region to region, soil texture, soil type, climate, but validating against existing methodologies might be one of those, or standardizing by recommending thresholds for the new technologies within regions. So those are some initial ideas that we're kind of kicking around for this group. Next slide. Here are the 5 reasons: soil health, restoration, sustainability, addressing climate action. No matter, looking at all of these things so that we can create a better tomorrow for our kids and our grandkids and our legacy in agriculture and in the world. Next slide. So the steps to collaborate on this would be to help us form this working group to standardize methodology to include new innovations in standardization. Next slide. And there you go. There is my contact information. And I'm actually going to open this up for questions because I left a little bit extra time. If anybody has any opinions, thoughts, suggestions, or just wants more information, do we have anybody from the audience that has an opinion on the topic?
For you or for the whole panel?
For me or the whole panel, but I've got the microphone, so.
I'll ask one. How do we think that we balance all the trade-offs in terms of making anything scalable? Because that's critical at farm level in terms of accuracy and scalability.
Yeah, so that's the cost point I think that you're making, that right now it's not cost effective. I'm going to speak on my personal experience. I'm a generational farmer from the Midwest. I actually live in California, so, but we farmed there for a long time, and one of the major problems that we have is that this is not cost effective for us. Some of the methodologies that have been proposed, again, in the Americas, are not cost effective for the farmer, so why would the farmer participate in something that's going to cost them more labor and more money for something that they might get in the future? So that's a huge problem. So new testing methodologies are all encompassing, including nutrient markets. So there's different markets that are emerging beyond the carbon market. So I would hope that next year we'd be including more markets like nutrient markets. So am I saving fertilizer that I put on the ground? Now that's saving me as a farmer actual money. Now I'm willing to participate, and how can I do that? New testing methodologies are what's going to get us there. We're looking at water quality markets. Those are different things that are out on the table right now globally. So beyond the carbon market, I think there's a lot of different sustainable markets that we're going to be seeing pop up here that are going to benefit the farmer in larger ways than we currently see. With just this one market idea. Did that answer your question?
Penelope, thanks for the excellent presentation. I would like to make the problem a little bit more complicated. Since we have talked that one size of methodology doesn't fit all, because beyond the actual measurement is the soil science itself that makes things a little bit more complicated. How you see the whole standardization process itself, when you mention all to work together, to really go ahead, take into account that we both agree that one size doesn't fit all. So how are we going to proceed in terms of standardization?
So I think that will have to be regional, and that's a great question. Thank you. I knew that one was coming. So when we start looking at soil texture, soil type, climate, all of these things are different, but we need an overarching standard to validate within any of those particular environments. So how do we accomplish that? Well, let's start with the baseline. How do we validate new innovations? How do we apply those innovations? Of the two suggestions up there, one of them was to validate the efficacy based on recommendations for a specific region. Again, based on my experience, and I'm gonna go back over across the pond to the Americas. The recommendations in my particular state in Illinois, where my farm is, are completely different than the recommendations in the state of Iowa. Most farmers practicing sustainability within the state of Illinois are actually going off of recommendations made by Iowa. It's the same type of soil, but because politics are involved, things get a little different. So what we're trying to do is create a standard method to validate new innovations so that there's no bias. There's no bias per state. There's no bias based on taxes. There's a lot of reasons that we end up with all of these different things. So an organization that has no horse in the game financially is how we do that, and then we can focus on regional changes, soil texture, climate, and things like that in creating a really robust method for validating innovations in testing.
that solves part of the problem, and I agree. And especially I would like to congratulate for proceeding with really standardizing the whole spectroscopy issue through i-BEC, and that's a great effort. Thanks a lot.
Do we have any other questions?
Today you put in the table the measurement of greenhouse gas emissions in the field, which is a second part, the second part before the measurement of the carbon stock changes in the field, which means that in the equation we have to put also the greenhouse gas emissions, or we have to consider it as a second step. And the question here goes to the fact that in Sahara Desert, we don't have carbon, so we don't have emissions. The more carbon you put in the soil, the more emissions you have. Fresh organic matter and organic carbon. Which means that when we increase the organic carbon in the soil, we increase the emissions. And in the equation, you put also nitrous oxide, which does not have carbon, but it has multiple capacity of absorbing heat. So if you make the multiplication about the carbon credits, at the end the farmer, he has to pay, not to get money. Because he is putting carbon that emits greenhouse gas emission. So in the context of carbon credit market, how we could confront this problem?
Well, I think we need to look at it holistically, and when we create a validation method, that would be of concern. So because your soil is different, obviously we need to take that into account when we're making a credit for carbon sequestration, insets, carbon offsets, insets, or greenhouse gases. So that's the regional part, and that's why it's important that we work together globally, because one nation should not be held out because of its soil type with regards to this type of market. Any other questions, comments, concerns?
Maybe at this point, I think we should open the discussion for all the panelists.
Okay, we got one more question, Kostas, and then we'll open it up for everybody.
Do you need me?
Yeah.
Okay, so I have a question for Georgios mainly. Can I address the question to Georgios?
Yep.
Georgios, you said that you recognized, you examined several methods of probably in situ measuring nitrous oxide, and you said that you find that the best is the NIRV, I think. And you propose this, to use this with the calibration with laboratory machinery. So, is this calibration one-off, or do we need to do this all the time? For example, for another, so if we have a new soil type, if we have a new crop type, is it something that it should be done continuously, or do we do it once off and we are done with it?
The second one. Because as I said that we are actually now developing all the systems, so I can't say that we have reached a level that we know from experience from the pilots and from many years that there is a point that the method it's going, that it's validated, that so we in the pilot so far we're using them all the way every year. We're using both methods, the most of the measurements with the sensors, and part of these measurements to calibrate and to validate. So the second option.
And I have another one for Nikos.
Yeah, please.
Nikos, I did not quite understand. Are you a company that produces fertilizers or not?
No,
No. Are you producing stabilizers or not?
no, we are
So
working.
What are you doing exactly?
We are working. We are a registry that actually we are developing methodologies in order to quantify and give guidelines to project developers. At the same time, we collaborate with companies like the Foodchain ID in order to provide from their side the verification and validation of the projects. And in the end, the impact units can be issued and then go through our registry, our company's registry, where the buyers can actually have their portfolio and see where they're coming from, and then they can purchase the credits from there. That is what we provide as a company. So we provide the methodology.
So you're not certification, let's say, company, right?
No, we are the registry.
You're working like something like a bank. You are keeping, the units, the credits, or not?
Yeah, we have the credits in our registry that the project developers issue through their interventions. For example, a project developer can be a farmer cooperative that works with a lot of farmers. We give to the project developers certain guidelines of how they can quantify their impact, how they can claim the reductions, and from then, what process, what steps they need to follow in order to issue their credits, starting from monitor, report their data, and then at the later stages, validate and verify them. The moment that is verified, then the impact units can be issued, the credits, if we can use a synonym, and then they go through our registry. From then there is available to buyers who are interested in buying these credits in order to reduce their scope 3 emissions. That's what we provide as a service. I hope it fits. Yeah?
When you're looking at enhanced
Fits.
fertilizers, are you also including the production emissions and higher production emissions that are created?
Yeah. Yeah. So the methodology and how it actually looks into the scope is that the project developer needs to provide information, what is the carbon footprint of their product from the manufacturing side until the farm gate. Of course, from the farm gate, the measurements happen based on the methodology. So before that, they need to provide information regarding the product carbon footprint, and then this is compared to the conventional one, to, let's say, the baseline. And from there, we have a delta. As you mentioned, some points when we have enhanced fish fertilizers, maybe their carbon footprint are a bit higher. But from this difference, the application side compensate even more on this delta, and you can actually have reductions.
Can you actually have the production emissions from the companies?
Yeah, we ask for the project developers, of course, to provide proof from the fertilizer company that provides the stabilizer, for example, or it can be control release fertilizer, whatever enhanced efficiency fertilizers. They provide information, approved LCAs, life cycle assessments, and they provide the reports in order for us to quantify the difference.
You successfully got this data because
I know it's a bit tricky. Especially the stabilizer one, by itself, as a compound, it has a super low carbon footprint. So the difference between a fertilizer and a fertilizer that actually the stabilizer have been incorporated in is not big. So sometimes we even need to depend and cross-verify the data they bring us to available studies.
How do you validate the emission reductions from those stabilizers?
We use, as I mentioned, I think I saw a slide where we actually focus ourselves on data collection right now. And what we're doing is that we look into available literature and we try to see what soil characteristics, all the characteristics of the experiment that happened. And then we try to correlate it with the actual project and the real world conditions. And we try to be as close as we can be to the reality. Of course, the emission factors we use, they have uncertain ranges. We always keep it conservative and we go to the lower range of the reduction. We never overclaim.
You make it specific to the situation. When
Exactly. There are specific contributor factors, we call them, which contribute to the effectiveness of nitrogen stabilizer to reduce emissions. And we use these contributors, for example, it can be the soil pH or the mean annual precipitation. And we try to correlate a scientific study or more with these factors to the actual project site. And this is how we quantify and validate the emissions. We are looking into the tier 2, which is making more regional specific and more project specific, I would say, because every region has, inside the region, you can have different characteristics of soil types. So we look into the specifics of the projects. We are going from tier 2 to 3, but of course we know tier 3 should be like data coming specifically from the project side. And this is where we can actually go a step further and use technologies like the one our contributors here, the co-session organizers mentioned in their presentations, that they can scale up our projects and have more accurate emission factors. Yes? There is no stupid question.
So if I see that there are farming practices, and those practices, so let's say nitrogen reduction is a practice that may be supported by the framework you are proposing, but then a farmer is also implementing cover crop that maybe is supported by Vera or somebody else.
No.
So my question is, now this farmer would use two different projects?
Yeah.
And in outcome, how do you...
Yeah, I understand your
You know?
question, that there can be more than one interventions on the same field. So, for example, the farmer can actually register with Vera to do a cover crop and with us to do a stabilizer intervention. And in that case, it has to be in a different project and different registry because there's no,
Then when you
integrate. So
when you distribute the outcome, how much goes sequestration goes for N, how much goes for cover
this
crop?
is based on the quantification. Of course, if I welcome all of you to look at our methodology, we talk about doing more than one intervention. It needs to be shown scientific proof, and we need to validate that these different interventions, they don't interact antagonistic with each other. And each intervention will have its own quantification by itself.
Okay.
So if there is an intervention between them...
Thank you very much for understanding my question.
No.
Maybe we talk later about it.
Yes, and we'll be here. Okay.
Thank you. I was wondering, how do you ensure traceability between the company all the way to the field operation for the units in setting?
Traceability.
Yeah.
Yeah. So currently, it was not in my slides. We are making a guidebook, we call it, where we give specific guidelines throughout the whole supply chain, how and where they need to provide proof in order for us to see that the green attributes are actually moving to the right way. So everybody can claim the fair share of this intervention. Yes.
Thank you very much. A question for Galanis. You have collected many data at the regional scale, and we have seen this morning the emergency to go now from 2026 in standardized baselines to have a baseline. Do you consider that the data you have can be a baseline, a good baseline for at the regional scale for your region? Farming.
So this is our scope. So we work on a regional level. So far with our data, because we have worked with a lot of different pilot crops at the regional level, and firstly we always do the zoning in order to know the microclimatic and soil zoning in the region. So we perform the pilots after we perform the zoning. So if we have the zones and we select pilots inside the zones, so for the specific zones and the cultivation, we can say that we have the baseline data.
To complete the answer is we believe and we hope that by the end of the land shift project, which is a flagship project for the European Union, we are going to have per each land use the baseline, not only regional, but for the European level. So that's what land shift is aiming at, to have the baseline for the different, for the non-CF anyway, for different land uses, after we doing the stratification per each zonation. But the final results will be by the end of the land shift project.
Can I add something on this with the land shift project? yes, it is on regional scale, but the operation is on living spaces. So we are now, we are about to, we have started to organizing the living spaces, which are living labs in a regional level, with all the data management in a regional scale, with regionals as not only as partners but as leaders of living spaces. So also this project is selected for policy recommendations about the upskilling in a regional level with all these databases. And what we presented today is how from the last year we are focusing on pilot level and produce data in a real life context with farmers, because our pilots are not experimental, are real pilots, and in the living lab. And we trying to make operational this real life context and produce data, cost benefit data. Yeah, just this.
Okay.
We have another questions. I think we have time for maybe one, and
Thank you. So first question for Nikos and one for you as well. Do you do any benchmark with your different calculation methodologies between themselves?
Sorry?
Do you benchmark your calculation methodologies between themselves or not?
Between?
You have different calculation methodologies, okay? Do you benchmark them?
Currently, you mean calculation methods based on the emission factors?
Yeah.
Yeah, we try to do some benchmarking, but still we need to focus on the appropriate data collection, so we are focusing on establishing a database, and then we're creating, I would say, a more aggregated approach on the emission factor usage.
Okay, thank you. And perhaps a stupid question, but will you be able to map all the acidic soil in Europe soon?
It depends on, of course, on the capacity of our servers. The idea is that for the moment we are going to deliver and make open source for sure the data of the pilots that we have performed in the project, because of course these are co-funded by ESA. We are discussing this also with ESA to understand if there is the possibility to host something even at headquarters level. But we are also open maybe to collaborate with some other organization, JRC and European Commission, if they believe that this might be helpful in order to develop a plot-based, plot level baseline. We are happy to share our and to provide our support in order to make this data available for everyone, of course.
Was it a yes or no?
It's yes for the data that we have.
Francesca, are you using the bare soils by DLR, the polygons for bare soils, the one that produced by DLR, and it's available anywhere?
Yeah, we are, of course, for the geometries and for some...
So the digital map, okay.
Yeah, but not only them, of course.
Okay, of course not all. Them I just want to make sure.
Yeah, hello, thank you. I liked your presentation. I was just wondering in which way you can use it. It's really nice that you can see where is the area where something can be done and where is the area where there's nothing to do. I was just wondering how you will deal...
Just one clarification. There are no areas where there's nothing to do. That's also why we are also working on urban areas. So it's just that there is more, they need more time and more investment in order to...
Yeah, my question went in that direction. How do you play with farmers' perceptions? Because you will be really face conflicts between farmers which can still achieve carbon farming and others can't. And so there will be, I think would be good also to pay farmers which have a red area, meaning that where it is more difficult and not only the green area.
I mean, I'm very happy about this question also because I'm here especially to receive feedback about what I'm presenting. I just want to highlight, and you will see if you will scan the QR code and have access, that usually those areas are mainly those that are located usually close to urban areas or that are in a very bad condition. So we do not expect that farmers are in this condition. So just to give you an idea, I showed later, some representation of some plots that were marked in red. These were from tobacco, so none of the other that were from rotational or arboreal crops were located in those classes, at least from the pilots that we have performed. So we do not expect to have this kind of problem, but for sure this is something that we have to deal. And in any case, if it is true that might happen that some areas are in the red part, first of all, as I said, it doesn't mean that they cannot become, host carbon projects, just that it's a little bit more difficult to restore them. And also that, on the other hand, it means that the incremental value of these carbon credits might be higher compared to the ones that are already at a good level and have no other capacity to store, or limited capacity to store carbon credits. So still there is an advantage for those that are in the bottom part.
I think we should go.
If there is no other question, I think we are running out of time. I just wanted to wrap up the session, an excellent session, and I would like to ask and close the session with Pauline's comment. Is the glass half empty or half full, Pauline? If the baseline is what we have discussed last year, Panos in Valencia, I think we can see that significant progress has been made in all levels, from MRV level, using all Earth observation techniques, satellite, in situ, laboratory, and of course, the standardization process, since it's an ongoing international process that helps us standardize our data and do all our intercalibration techniques, we can have valid data to use amongst us. And of course, we have something like a repository here in Europe that starts, Nikos has shown us how this proceeds. To me, and of course I'm biased, taking into account the baseline that has really produced last year in Valencia, here in Dublin, I think we have seen that some significant progress has been made, and we hope that by the beginning of 28, we can have tools, all tools required, as it was mentioned this morning in the plenary, that we will have the farmers, the engaged farmers, the appropriate tools to really get into this one side Pauline business model, but anyway, some valid business model that really can help the farming society as well, of course, benefit the climate adaptation that we are going through. So thanks a lot for being with us, and we hope that next year we will see more dramatical improvement in the tools that we are producing. Thanks a lot.
Thank you.